So again, I have basically whatever goes on in the class. I've been putting, I've been getting used to the routine as well. So I've been actually putting them up on Canvas. But so you can actually see whatever we went through in the class during, in every session. So if if you missed the class or you just want to review stuff that was said, you can always go back to that. And again, sort of considered as a high tech, I guess, sort of notes. I actually always update the lecture notes to be a little more resembling what the slides that I put on for the PowerPoint look like. So so check those out as well, especially as we starting to get ready for the next exam. Make sure that you use those to study. All right. Again, so no questions. Everybody, I guess as usual, very quiet. I'm gonna get moving on with the lecture. All right, everybody set? Okay. Okay, so again, let me know in the chat if you let me know in the chat if you, so you should be able to, by now you should see, by now you should see a screen where it talks about mid-lateral cyclones. Yes, you already seen that. Again, you can see the screen. Great.
Yeah.
Yes. This is sort of where we left off last time. Everybody hear me okay as well? I didn't put my, sometimes I have headphones, but I find out that with the headphones you can't hear the sound of it when I put videos on. Anyway, all right, so this is where we left off. We're talking about mid-lateral cyclones, which remember that we talk about the different fronts. We talk about these masses of air that move around. They're pretty big. They can take half of the country, and as they move through, pushed down by the jet stream, they can be cold, they can be warm, and then they usually, you can see them on the maps, as you see like right there. You see them on the maps either cold or warm. Remember those symbols? I'm going to ask you about that in an exam. And so what happens is when basically the two sort of come together, the cold and the warm get together, they stop, and they, like we call that, remember, we call that a stationary front, where the two mix and they just kind of stop. Eventually that leads to occlusion, which basically means the death of those fronts. They just stop, they die. But right before that, when they are stationary, even though they sort of stop advancing, as you can see in the picture, they begin to create a cyclonic movement. A low pressure system is created, and they begin to move. They spin, and remember that on a low pressure system, they spin counterclockwise, like you see in the picture. Once that happens, again, we create these mid-lateral cyclones. Usually, again, depending on where they are, they're picking up, like you can see in the picture here, they can pick up cold air from the north, and then they can pick up warm air coming from the Gulf of Mexico. When that happens, if let's say the warm is really warm or the cold is really cold, you can create serious disturbances in the atmosphere, like tornadoes, which is what's happening, especially this time of the year. We're starting about the peak of the season. The peak of this tornado season is around May, but we're starting to already see a lot of cyclones. And what is happening is that these mid-lateral cyclones that are created sometimes can lead, not always, sometimes can lead to like tornadoes and other disturbances. And so again, so they start spinning, and depending on the stability of those of that warm air that is rising, and as they collide, it can create a lot of precipitation in some cases, or like I say, some very serious disturbances. Right. Now again, the warmer the air is, particularly the warmer air that comes from the Gulf of Mexico, when it's really, really warm, it's going to rise very, very fast. And when it rises up very fast, it's going to be unstable, and which means it's going to create serious disturbances in the atmosphere. So like I said, I showed you this before, I think right before we left. Now, remember that these cyclones, of course, they're low pressure systems, but because they are not in water, they're not as strong as hurricanes, which I basically call, they're basically tropical cyclones. That's the official technical name. Tropical storms, but eventually lead to cyclones. But because they're not on water, they don't pick up a lot of the energy from the warm water. We'll talk about hurricanes in a few minutes here. They tend to be milder, but again, depending, particularly in the Midwest region, where you have warm masses of air coming from the Gulf and still kind of cold fronts coming from the north, it can create some serious disturbances. And I think I might have shown you this before as well, sort of how these mid-latitude cyclones, no, that's not the one. This one, yeah. You can see sort of how they move. And again, some of them can be pretty strong, and if they're very unstable, they can cause a lot of disturbance. Sometimes in this time of or in the winter, like we had a couple of occasions last year in Colorado, these can create what they call polar vortexes. When they create polar vortexes, they can bring a lot of really cold air from the Arctic region from the north, and they can create massive cold spells, a lot of snow, ice, and really crazy stuff. And some of those storms can be pretty strong, but again, nothing compared to a hurricane, but they can be really strong in some cases. All right. You guys ready for tornadoes? I know you want to get some of the crazy stuff, and everybody always likes this stuff. So again, we have to talk about some of the basics of how air masses move, what happens when they interact with each other, and then in some cases, the next few tornadoes, hurricanes that we're going to talk about is when the disturbances get really heavy, and they can be very destructive, such as the case with tornadoes. Again, we are just about to start the tornado season. I'm going to explain in a minute what that means and what are some of the implications. But you can see that, you can start hearing the news. Actually, they just had one in, I think it was in the south, around Alabama, Mississippi, some of those areas. But most of them eventually going to end up happening around the Midwest region, or they call it Panhandle of Texas, and in Oklahoma. That's where most of them happen. But anyway, so a tornado is basically, as you can see on the slide there, it's a localized cyclonic, remember, low pressure system that is surrounded by a whirling cylinder of violent wind. And so they're very violent. They're really small and extremely localized, meaning again that they are, they're not happening in a big area. They happen in very small areas, as is the case usually with hurricanes. With tornadoes. Even if the big tornadoes, some of the really widest tornadoes that we have seen, there's still nothing compared to the width and the extent of, like, say, a hurricane. They tend to be relatively small. Now, remember from chapter 5, when we're talking about pressure, what happens in a tornado is we're going to have some very extreme pressure gradients, which means that, again, the changes from high to low pressure, remember, always going from high to low, are extreme. And so the gradient, and usually what happens, remember what you guys will happen, you can type it up. What usually happens with a extreme, with big pressure gradient? What happens when you have a big difference between the high and low pressure? Anybody? I should start giving extra credit if anybody answers. Nobody says anything, so. Anybody remembers? Type it up in the chat, or unlock your mic and you can tell me what happens. What happens to the wind when you have a big change from high to low? Remember, it's always happening like that, right? Always going from high to low. So what happened with the change is really, really big. So let's say, remember that I was talking like a ramp. So the high pressure is really high and the low pressure is really low. So that means you have a ramp that is a lot steeper. So when you have a steep gradient, right, that means that the speed of the wind is going to be a lot faster. And so that's exactly what is happening here in a tornado. The pressure gradient is extreme. Is the differences between the high and low are huge, and so as a result, you're going to have some really, really extreme winds. The speeds of the winds are going to be.
It changes the gradient changes.
I'm sorry.
The gradient changes, isn't it,
Yeah,
with
that's
the
what I'm saying.
temperature?
Remember that I was just asking you briefly to do a review from what we did in chapter 5. I know it seemed like it was years ago that we talked about that, but you know, pressure goes from high to low. Remember the balloon that I showed you? Always going from high to low. That's how it always does, right? But
Hmm.
higher the higher pressure is and the lower the low pressure is, it's going to be a big difference. That's called the pressure gradient, right? So the bigger the differential between the high and the low means that the winds are going to be a lot stronger. They're going to be faster. And so that's what happens here in a tornado. The gradient is extreme. The high pressure is really high. That when some of the winds are coming from, it's going into a low pressure, which is what's causing the whirling cylinder, and so as a result, the wind is really, 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 really fast. So again, we have an extreme pressure gradient with a tornado.
Okay.
Yeah, extreme winds. Anyway, so that's what happens here. Now, there's other conditions that are going to lead to that wind creating what we see as a tornado. So the winds are going to be very fast. And again, the other thing that is happening is it's very unstable. Remember, stability is usually when the warm air, remember, warm air always rises. As the warm air is rising, in this case, in the case of a tornado, it's moving very, very fast, extremely fast. In fact, it's so unstable that in some cases it doesn't even get, remember the adiabatic process we talked on chapter 6? It doesn't even get a chance. I mean, it will create condensation once it happens past certain temperature. When it cools down to a certain temperature, it starts creating clouds and so on. But in some cases, the instability of the air, the warm air is so unstable that it's rising so fast that in some cases it's not unusual in a tornado to have hail associated with it. Heavy thunderstorm type of conditions, lightning and stuff like that. And that's again because the warm air that is rising is very unstable. Usually they are created above ground, and they are, you have a lot of this water vapor that is sitting out there that begins to sort of concentrate, and eventually, due to winds, and in fact, in the case of a tornado, I'm going to explain. I'm going to go through some of the technical details. I'm just giving you the basics right now. Because you have winds coming from three different directions, they create what is called a rotating vortex that eventually, again, lead to what we know as a tornado. Now, here's a couple of the things that they need. So you need again high pressure gradient to begin with. You're going to need a very unstable warm air that is rising. And you're going to have wind that is coming from three different directions. Some that is carrying the water vapor that is up in the air, others that are coming from the surface that are usually drier types of wind, types of air. And then in some cases, air that is coming in the opposite direction, again, leads to the vortex. The other very important thing, and that's the reason why tornadoes don't happen everywhere in the world. In fact, we'll explain where is the most likely place for a tornado, where is the place that they usually happen. They need flat land. They cannot, kind of like a hurricane. We'll talk about that later. In a hurricane, you need water. Well, for a tornado to continue its path, you need flat land. It needs to be flat. Any kind of topography, any kind of mountains, is gonna kill it. So they need to have some flat land and need to be able to continue. And so very few places in the world have these conditions. I think most of you have seen, I'm going to show you some videos and so on. They can be as thin as the one that that you see up on top, or as wide as the one that is shown below. Like a, a wider tornado than those, like this one here. And the vortex varies. They can be really wide, like you see again in the one on the bottom here. They can be relatively thin. So the conditions vary so much. And just like a lot of stuff, we still do not understand everything. I'm going to go through some of the technical, I'm show you some videos of how they are created and what are the conditions that lead to it. But as many things in science, we still do not quite understand how they actually form in with certainty. We also do not understand. They're hard to predict. We can see them coming, but they can pop up in a second, literally. From you can see an area, okay, the conditions look like there might be a tornado forming. Boom! All of a sudden, you have a tornado moving, and within 10, 15, 20 minutes, it can destroy. It can cause a lot of destruction, like you see in this area. Now, again, this is one of the reasons why we call this localized severe weather, because again, it's not like like a huge area, like a whole state, or even like a whole town, a whole city that is actually involved. It could be just a path. It can take an entire neighborhood, and then the neighborhood next, a few, couple miles next to it is going to be unaffected. Nothing is going to happen to it. And it's not unusual, again, to see tornadoes going through, destroying one neighborhood, and the neighborhood next door being totally intact. So anyway, so again, these things that we have to remember, basically, again, stream pressure gradient, very unstable warm air rising, usually need like basically three different types of winds that lead to creating this funnel cloud that they talk about, and then eventually the rotating vortex. And they need flat land. Right? It cannot happen in areas that have a lot of topography. So I'm going to tell you about, in fact, the United States, the Midwest, which is actually referred to as Tornado Valley. It is the place where most of them happen in the world. And so I'll talk about that in a minute. That's information. Any questions about, again, these are the basics. I'm going to show you some of the mechanics of it, how they are formed and what happens. I'll show you some videos. Very good?
Yes.
Questions, you can type them out. Right? Okay. So again, you can expect a question. Let's say I may write, like I say, I usually don't like to do negative questions, but most cases say, the following is one of the reasons, one of the conditions that will lead to a tornado. And I may put three that are not, and I put the one that is, and you have to make sure you identify or you understand that there's certain conditions that are needed for a tornado to happen. All right.
Okay.
Talk a little bit about the mechanics, how they are formed, and then like I said, I'll show you some videos that we'll see them in action. So again, I'm gonna sort of write these things with a little bit of what we just spoke about a few minutes ago. Then I'm gonna show you one video that talks in very general terms from National Geographic, and then one that talks a little more about these mechanics that I'm just talking about here. Right? So it's going to require what is called a wind shear. Remember that we need to have winds that are coming basically from different directions. And there are actually some that are actually in the higher levels of the atmosphere, or at least higher, not necessarily just tropic, but higher, and others that are lower closer to the ground. That's usually what we call a wind shear. It's wind that is coming in, and that at some point it changes. It changes the direction and the speed. They're coming in at different speeds, and they're coming in from different directions. Now, usually we have winds that are usually coming from the west, in the United States, the westerlies, and they usually will be a lot drier. In areas, for instance, in the Midwest, where most of them happen, they're coming in from the west, and in many cases they're going to be, because they have just gone through a lot of the middle of the continent, which tend to be a lot drier. They bring a lot of these winds, right? And now again, here's also what I was just talking about earlier, that we have warmer winds, in some cases, very warm wind coming from the Gulf of Mexico, for instance. And that warm is going to create what is called updrafts. This is a very unstable, warm air that is rising. It's going to start rising vertically. That's why it's called an updraft. And it is going to encounter the horizontal wind that is coming from the left, from the west, and eventually it's going to lead them to create a funnel. We call that funnel is called a mesocyclone. It's a cylinder that basically of rotating air. So again, we have these horizontal winds like you see on part A right here. They're coming through, and as they're pushing in, they encounter the updraft. This is the third wind that I was telling you about. And this is usually the very unstable warm wind. They're usually warm, and it begins to push up that horizontal air that is coming from the west. As that happens, that that air begins to lift up and begins to sort of create a funnel going up. That's called the mesocyclone. Remember, this is very unstable air, so that's when you start seeing condensation being created, and again, in many cases, it's being created very, very fast. That can lead to hailstorms and so on, or just simple thunderstorms like lightning and stuff like that. Once those three forces basically, they at some point they're gonna lift up the mesocyclone, and it's the mesocyclone is gonna start spinning. But anyway, let me show you first. I'm gonna show you the introduction to the tornadoes from National Geographic, and then this that I just said is going to give you a little more technical details as to what happens within the formation of the cyclone, of the tornado. So here's the first part, and I'll get back to this. Okay, so we'll explain it in another animation. And let me know if you hear the sound. So, you guys hear the sound? You hear the sound
Yes.
from the Remember this part. Ask about it.
Mm.
Now, there are people that are actually studying these things. They call them tornado chasers. I think they used to be like some shows. I think I was just looking at Netflix or whatever it was, a Prime Video that they had. They still have people, chasing tornadoes. And in fact, I have a friend who teaches at the University of Oklahoma, which is like the epicenter of research going with tornadoes. And when he was a graduate student, I mean, that's usually what they do. They send the poor graduate students to do crazy stuff. So he's actually one of those tornado chasers. And they'll go out and start measuring stuff. And he's trying to understand what happened. It's a lot. He keeps telling me the technology. There's a lot of new technology that they now have. They can actually put like these devices where they expect the tornado to go by, and they can go pick them up later, and literally even have video that can see what's going inside. Again, he keeps telling me, I mean, we know a lot about them, but not enough. We just don't understand why a lot of things happen. Anyway, so I'm going to talk a few more things about it. Let me show you the other more technical that kind of explains what you have in the picture on the picture here. That is going to give you a little bit about a little more technical explanation of how these things are formed. I gave you the conditions earlier, where that is what is required for it to happen. But here's a little bit more of the details. A little more technical. Anyway, so again, that was just a little more technical that just explained. But again, it just those factors that I explained before. Um, you have to have these three different types of winds. It has to be flat. And again, usually you have some that are cold, some that are warm. The warm one is the one that is going to create a very stable conditions. That draft that they're talking about, that draft eventually is going to go up. It's usually warm air. And if it's very, very unstable, very warm, rising up very fast, it can then create the funnel that usually creates a tornado. Any questions about these?
No.
It doesn't sound like fun to be a tornado chaser. It's very dangerous, but I still watch it. I'm going to show you some of those, some of these tornado chasers because they still don't understand everything. But my friend tells me that the technology is amazing and they're learning a lot of stuff about it now. Anyway, so here's how this is a global map of where they happen, as National Geographic video showed. Happens, 3/4 of them, 75% of them happen here in North America, particularly right here, right around the Midwest, what is called Tornado. This whole area is called Tornado Alley. I mean, remember they extend also to the south. We've been increasingly, and we'll talk about climate change later on. this area of the United States have been abnormally warm this year in the winter, and expected to be really warm in the summer. And so more and more tornadoes are actually happening here as well. In Alabama, Mississippi, they had some really deadly ones in Tennessee, late March.
Kansas.
Yeah, Arkansas is having some. So this whole area right here again is Tornado Alley. That's where most of them happen. We do have them occasionally happen in other areas, but here's where they're gonna happen most of them. And then you can compare to the rest of the world, and you can see that there are very few places that have those conditions. They have that flat land. They have that conversion of three different types of wind that create the ideal conditions for a tornado. So most of them are going to happen in the United States in that particular area in the Midwest. Um, a few more things about Tornado Alley and the reason why they call it Tornado Alley in this map. In the United States, you see the frequency of tornadoes. I mean, look at our area here. They happen very rarely. In fact, once in a while, when we have in the winter, we have some of these storms that come in from the north, we may have what they call water spouts. And there have been some cases where we have water spouts like off LA, like, off the coast out there. But very rarely, extremely rarely, are we going to have an actual tornado here in California. We just don't have those conditions that are required for that. But you can see by 9.0, here's what we call the panhandle. This is the panhandle of Oklahoma. And here's the panhandle of Texas. The panhandle, like rather the pan, right? And so those areas right there, you can see that that's where most of the tornadoes will happen. This whole area right here, most of them will happen in Oklahoma. Again, you have some as you move to the south. Florida has a good portion of them, but you can see the frequency of those. Here's the season for tornadoes. Here's again, we are approaching the peak season. You can see that they're starting to, as we move towards further into the spring, April, towards May. May is the peak. That's when you look at the number of tornadoes that happen in a given month. Now, of course, not all of them are extremely big or destructive. Just like a bunch of other phenomena, some of them are just going to be very inconsequential. It may just happen for a few minutes, some cases a few seconds, and they're just going to go in and out, and they're not going to cause, they're not going to watch, you're not going to hear them in the news and anything like that. But for the most part, again, you can see that right now we're starting to approach the peak season, which is usually around the middle, at the beginning of May. And they go basically all the way through June, which is also, that's usually when the peak season ends. And again, they happen at other times of the year, but this is the time we're heading right into the season. You can also see in terms of, now I'm going to talk a little more about the way that we measure tornadoes. I'm going to put it up there. And the National Geographic video talked briefly about it. Here's where you have to be real careful with this, because I'm going to ask you about this in an exam. The way that we measure the impact of a tornado is called the enhanced Fujita scale, the EF scale. And now the scale is not measuring the speed of the wind. They can tell you what the speeds are based on different scales, but what it's actually measuring is the level of damage. Right? The zero will have some branches broken, trees uprooted, right? Some damage, but not that much. But you start heading up, say towards the two, now you're starting to move. Mobile homes are being pulled out, roofs blown off, objects get thrown around to become missiles. You get to 3, where trains can get derailed. 4, when you can have foundations of some homes being lifted up. Houses that are well built are destroyed. In fact, and I haven't lived out there, and they terrify me, but I don't think I could live out there. But a lot of places in the Midwest have basements. And one reason they have basements is because on a tornado, the top of the house can be basically lifted up and torn apart, but you can hide in the basement and you'd probably be safe. Anyway, and so again, once you get to the 5, scale. I mean, we're talking entire houses being blown up. I'm gonna show you some videos here that show basically vehicles being picked up, semi trucks being lifted up and thrown around like little toys. And so, again, the enhanced Fujita scale, the EF scale, measures the damage that the tornado causes, not the speed. Right? Now, if you look at the map again, you can see different levels of intensity. Again, you can see, and this is showing more towards the south, a little bit away from Tornado Alley. But you can see again, we just have some in Tennessee. You can see Tennessee has a large number, and these are the ones that actually have occurred. I believe it was from what period of the year that was. It was a 27-year period. Um, uh, so the past, you can see the past. This is just one season. In April 25th to the 28th, 2011, it shows you the past that some of these tornadoes took. The chart on the map on the big map on the left over here, it's a 27-year period of intensity, the frequency of different tornadoes. But this one right here at the bottom, this one that I'm pointing out right now, shows you the intensity. You can see in Tennessee we have some EF5s, which are extremely damaging. Again, tearing up, and you can see a lot more in Alabama, Mississippi. In fact, those are the ones that we're having right now. This area tends to have them earlier, and then eventually, as it goes on, they move over to really intense ones happening in May in Oklahoma. Anyway, let me show you some videos of some. I just updated some that happened from last year. So let's see, let me show you those, some of the, it has like a quick summary of those that happened in the tornadoes that happened last year. And I'll keep it updated. And I'll show you some more with show a lot of devastation. YouTube gods work with me today. This is just different tornadoes happen at different times. Show different types of funnels and stuff. This all happened last year, last tornado season.
Can it be more than one at the same time, or no? Because I saw on the left-hand side a very tiny one forming.
And there's seasons like that where they happen, two happening side by side.
Oh wow!
It can be even more than that. I've seen pictures or video of some that are, it can be 3 or 4 of them. You know, and sometimes they combine themselves, like you see in many cases. They get combined and then they get really big and really wide. Again, the mechanics of them are, and that's what a lot of these scientists are trying to understand. But width of the funnel, there's all kinds of factors that, there's so many factors that are so complex that it's very hard to predict. And in fact, the path of it is, they can tell you this area, they put them under a tornado watch, but it can be in many different areas.
Oh my gosh.
Mm-hmm.
That's scary.
They are they freak me out. I had a debate with a friend of mine, tornadoes or thunderstorms versus earthquakes. I can't understand how you guys can live with earthquake shaking. I can't understand where you guys can live with tornadoes like one for it's thunderstorms.
And then they ask us, I can't understand how you can live in California where there's earthquakes.
That's what I'm saying. Yeah, I can sleep through 5,
Yeah.
I don't know if I could do that with seeing a tornado coming up.
I mean, it would be fascinating to see it from far, but not being in the middle of it. For me.
Yeah, and the worst is when they sort of come in, they may not. Notice that there's usually sometimes lightning going on, and in fact, a lot of cases, it's hail. As they actually go into an area, you'll see lightning, thunder lightning, and then you'll be hail. Again, the air is moving out very, very fast. allow instability.
Mm.
I have one more, I think that I just checked out the other day. That
Wow.
I'm just going to share a little bit on that because they focus is on Tornado Alley. Uh, I'll post this on canvas. Anyway, so like I say, it's just I like the first part that focuses on tornadoes and some of the things that happen in Tornado Alley. But again, I'll post this on Canvas so you guys can watch them in more detail. Those of you who are going to do the extra credit videos, I have a bunch of about hour, 45 minutes to an hour long, usually by Nova or some other uh, public television type of documentaries that talk a lot in detail about different tornadoes and specific tornadoes in certain parts of the world. All right. So anyway, any questions about tornadoes? Pretty scary, but I think it's fascinating to watch. I show these videos and like I say, I'll post this out. I think what I'm starting to do now is, especially now and on these when things are going on, and I do that on online classes. I usually post a lot more things because we don't. But so since we're now doing this a lot online, I'm going to be posting a lot more videos on Canvas than I normally would. All right. So,
Good.
okay. Um, look at a few other aspects of localized severe weather, and that has to see with lightning. Lightning is basically an electric discharge in the atmosphere, and it usually happens particularly on cumulonimbus clouds. Remember, cumulonimbus clouds are those clouds that are usually created by vertical movement, call them outdrops, right? And there's actually a downdrafts as well. But when an outdraft happens, you have warmer that is moving very rapidly, very unstable. And as it's moving up, it's creating clouds. Usually the cumulonimbus, especially the bottom part, is going to be it's going to be wet, and that's usually when the rain is going to happen. So what happens with lightning is that the negative charges focus at the bottom of the cumulonimbus cloud, and they all become negatively charged. They in a cloud, you're going to have both charges because you have basically water vapor, water that is actually being created in a cloud, and so you're going to have positive and negative charges. The negative charges are going to get down to the bottom of the cloud, and now usually the ground is positive, and that's when we talk about grounding yourself and all that. Is you sort of putting yourself, you're neutralizing basically the electricity you may have up in the air. And so here's what happens usually when you have this situation happen, we have this really unstable air rising up that is become negatively charged. It's usually going to react with the positive charges that you have on the ground, and the result is usually going to be an electric discharge. Right? But it is sort of what it's trying to. It's like the same thing that happens when you go and maybe it's a floor that is very like carpet, and you touch metal, and you actually create an electrical charge. Obviously, you're not going to see sparks coming out because it's not that intense. But the amount of electricity we're talking about is huge, it's massive. And so you're actually going to see these charges, and that's what you see with lightning. I'll show you a video in a second as well. Now, they usually have very close to the ground because, again, you having this cloud, the bottom of this cloud reacting with the ground. Now, what usually happens with thunder is sound waves that are basically happening as a result of that electrical charge. Right? They happen at the same time, except that lightning travels at the speed of light, 300,000 meters per kilometers per second, something like that, real fast. Where sound travels a lot slower. In fact, the thunder that you hear is not necessarily the one from the most recent lightning that you saw. The thunder you may see is one that from an electrical charge from a lightning that happened perhaps a few minutes before. The thunder is basically a boom. It's a boom sound. And sort of explain that, like say, I'll show you the video in a second here. I don't know if it's anybody, and you can write on the chat here. Has anybody ever seen a transformer blow up? Let's say you have the transformers that you usually have in the streets. We have light cables and all that stuff.
Once I heard one. It was loud, like a thunderstorm. Yeah, like a thunder.
Yeah, that's exactly what that is. And so when those transformers blow up, when they blow up, they make a cracking sound, right? And because it's a huge amount of energy that she's got discharged. I had one happen probably about 200 feet from the apartment complex I live at. It was one right outside, as we get out on the road. And it blew up, and I mean, all of a sudden I hear windows rattling and everything. So, power went off. It usually happens when that happens. It's so much energy, so much
loud
power that just creates a crackling sound. That's what thunder basically is. So let me again. It sounds like they basically happen at the same time, or sometimes you hear the thunder and you say, "Oh, that was just from the lightning that just happened." But it could have been that was from like 5 minutes before, because again, light travels a lot faster than thunder. So let me show you this quick little video that I think it gives you a lot of explanation, a lot of illustration. Yeah, so you know how it said like in the United States again. This could be a question. Oops. Yeah, YouTube has a habit of just keep on putting going to the next one all the time. So yeah, so if you so what happened that most of the lightning happens in Florida, and believe it or not, the biggest reason why the people that are usually the lives that are lost is people that are actually uh, people. What are people saying? No. Somebody saying no. Anyway, I don't know what that. It's probably a question that I asked before. Anyway, so in Florida, of course, you know a lot of people play golf out there, and so a lot of the people that die, hit by a lightning strike are people that are usually outdoors and largely playing golf. Again, so again, this is I told you guys that I'm definitely petrified of lightning and thunder, all that stuff freaks me out. And so I remember, all these things. Oh yeah, don't like. I used to like when I was a kid, like they used to tell me, oh, you have to wear a hat or something because if your hair will attract the lightning. And so when I mean, most of them was thunder and lightning going on, I would just go inside, but all these things, and it could be true. I mean, you can cover your head, but it's away from likely you can be hit. Anybody knows of anybody getting hit by lightning, or you seen any crazy lightning somewhere? There's a lot of in Mexico. I remember, vaguely remember because I was a kid, but growing up in Mexicali, we have them in the summer. But I had some say these things freaked me out so much. Probably why I became traumatized by them. Because I remember when I was living in Michoacan, when my dad is from. Man, there's lightning, thunder all the time in that area. And I remember just being totally terrified by all the stuff going on. So, but anyway, again, we don't have it that much here. Once in a while, we have a really strong cold front coming from the north. It clashes with the tropical fronts that come from the tropic, and when that happens, usually, or sometimes we'll have some in the summer. Yeah, yeah, a lot of them you see a lot of them in the mountains and um, uh, in Mexico and in many parts of the world. Like if you remember the other part that you say that in the United States is Florida, but you saw the Himalayas. It's another area where they happen a lot in the Congo and tropical forests of the Congo. The mountain areas tend to have a lot of chances of thunder and lightning going on. All right. So let's move on to hurricanes. Hurricanes, the official name of a hurricane is tropical cyclone. They are, that's the official, that's the technical name, but they're actually called different things in different places in the world. They tend to be very violent, large, massive, low pressure. Remember, cyclonic, meaning low pressure, cyclonic storm. In some cases, they tend to be smaller than the mid-lateral cyclone that I was talking about earlier, but because they are moving on water, they pick up a lot of motion, they pick up a lot of energy from the water, especially in the summer when the water is really warm, and they pick up intensity, and then they usually pushed out by either the trade winds and the Caribbean, and then at some point get picked up by the westerly,
Eso es eso.
the west, creating conditions for this hurricane. Now, here's the deal. The big difference from this mid-lateral cyclone that I was talking about, they are formed over water, over warm ocean water. They never happen on land. In fact, when hurricanes hit land, usually when they make landfall, that's when they die. They're usually going to dissipate once they hit land. I'm going to tell you the different names that they're called, but here are some of the rules about when tropical storms, and usually when it starts, when they eventually become a hurricane. So based on the speed of the wind that they're moving on over the ocean, they usually start out as a tropical depression. So for instance, the one that we get here in the Caribbean, they're gonna get, they're gonna build up somewhere around the tropical region, and they usually gonna start in the middle of the ocean as a tropical depression. They're gonna pick up speed, and then they become a tropical storm, right? And then once they hit 74 miles per hour plus, which is what 100 and so a tropical depression, usually you have winds of about 30 miles per hour, 61 kilometers. A tropical storm, at some point, you go from 63 kilometers, 73 miles or so. But once they hit 74 miles or 119 kilometers per hour, then that's officially a hurricane. Now, here's the deal. Once they now, they, like I mentioned, they are called different names. In North America, what we deal with them here, they call them hurricanes. And I know in Mexico, a lot of them they call it ciclones, right? That's cyclones, right? But in most of North America, they call them hurricanes. Over in East Asia, right under this area right here, this area right here, they call them typhoons. So East Asia, Australia, they call them typhoons. In fact, in the Philippines, there are typhoons as well. They usually call them two different names, but they also call them bagyos in the Philippines. So
I'm sorry, how do you say that? Bayous?
bagyos, just like the word looked like, and it's like you would say in Spanish, bagyo.
Okay.
But they're typhoons. Most people in East Asia are going to call them typhoons. Again, some Filipinos, I think it's Tagalog. They will call them basically same type.
Yes, Tagalog.
In Tagalog, yeah. And so, yeah, they call them bayous. Around India, in the Indian Ocean, they call them cyclones. Just like, like a lot of people in Mexico call them ciclones, right? And in some parts of Latin America. So anyway, so usually what happens, that's how we call them, but they're the same thing. They still start tropical cyclones, they still what we call hurricane. So again, they start out with tropical depression, they start picking up speed, tropical storm. Once they hit 74 miles per hour, they're officially a tropical cyclone, they're officially a hurricane. Now, usually around 40 miles per hour, which is somewhere around the time that they become a tropical storm, tropical depression usually happens around 30 miles. So once they become a tropical storm, they're given a human name, around 40 miles per hour. And so they're given a human name, and they're going to be naming these storms or these hurricanes as they appear in order of appearance. And they're going to start building up as tropical storms and then by the time they hit 40 miles an hour, they're going to have one. In fact, I put an article, I think one of the ones that you wrote this weekend, that they already have names for them. So as they begin to appear, right, they're going to start giving them names. It was interesting because in the past, and some more probably too young to remember, but I can remember that a lot of first of all, the names of the hurricanes used to be males, all males, and also anglicized, like George and Philip and that kind of stuff, right? And eventually people say, well, wait a minute, why, so then they start including names of women. Then okay, they can have names of women, but they're still anglicized. And people say, well, you know, a lot of them are happening in different places that are not just you know, English or anglicized. And so they now start, you know, now we have Maria, we have Jose, and you know, so they sort of become very much.
That's good.
Well, yeah, you know, unless it happens, like I know I have you know, I have nephews or nieces that are named. Of course, a lot of them are called Marias, right? But so when he had Maria, I'm like, yeah, I don't know if I'm really identify with that very destructive hurricane. But anyway, yeah. But
Yeah, my husband is named after a hurricane. When he was born, there was a Hector huracán going
yeah,
through.
yeah. I think I knew some students.
That's messed up, though.
Yeah, I had a student that was called what was not Ivan, but what's the Spanish what's the Ivan is in English Spanish. Yeah, yeah. Anyway, Ivan. I think yeah, it was Ivan. And yeah, there was a hurricane. It was named Ivan. It was really destructive. 10 years ago. But anyway, so they're pretty massive, and you can see it from satellites. Here are some old ones. This is a typhoon. So here's what's happening now that a lot of these hurricanes are becoming extremely massive. I'm going to tell you how we measure the actual how we rate them, the damage and all that. But they starting to get really, really big. In fact, now they're looking at a new category for typhoons, or you know, hurricanes too, because once they go past 150 miles per hour, winds of 150 miles per hour, then they are no longer just a hurricane or a typhoon. I call them super typhoons. Climate change is making the water warmer. They're becoming intense and like I say, it used to be that we usually will have every 3 or 4 years we'll have a category 5. Well, 2017 when we had Maria and so we had all those hurricanes and they were like 2, 3 category 5s in a row. Anyway, so expecting this year's season is going to be pretty crazy too. Somebody's talking. Anyway, all right. So here's a little bit about how they are formed. They tend to happen usually at the end of the summer, at the beginning of fall, and I'm going to explain the reasons why that happened. They has to see with some stuff we already know. But they tend to be, again, very low pressure. That tends to happen around the tropical region, somewhere between 8 degrees of latitude. That's what they actually get informed. 8 degrees of latitude and 15 degrees of latitude, a little bit above the equator between the tropics. Again, in both hemispheres. Right? Now remember that summer and fall are going to be opposite in different hemispheres. So in the northern hemisphere, usually after May, we start heading into, once the summer begins, is when we begin to head into the hurricane season. So they always are created in the middle of the ocean. Like the picture that you see here, this is for Katrina, I think. They usually start right over here. They start forming right in the ocean. Again, they need really warm water, and that's usually why they're gonna happen at the end of the summer when it's the warmest, and sometimes around the beginning of the fall as well. Usually what happens, they are getting pushed in, like say in the Caribbean, in North America, where we get most of them out, they're gonna be pushed by the trade winds. Remember, the trade winds are moving east, the easterly. They're pushing, they push the hurricanes over towards the Caribbean, coming from the east. And so once they get to, say, the Gulf of Mexico, right, at some point they're going to encounter, so again, the warmer the water is, the more speed that they get. Many times when they get to the Gulf of Mexico, the Caribbean, the water is extremely warm, sometimes warmer than where they got formed. And so in many cases, they begin to pick up speed. Right? Now, when the direction of where they're going to end up, is they're going to end up in, say, in the Gulf of Mexico or in, what they call the Riviera Maya, the Maya Riviera, and you know, around parts of Quintana Roo, Campeche, Tabasco, those areas, or Yucatan, or is it going to head towards Miami, towards Texas? And that's going to depend on the speed of the winds that are coming from the west, the westerly. The westerlies are going to be, the strength of the westerlies is what's going to determine whether they hit the Gulf of Mexico, the edges of Texas, or whether they're going to go all the way to Florida and they keep going up to Carolina. And so those factors are basically what determine where they are. So you can see the complexity of it. I mean, you can see the past, and in fact, what you see in this picture here are past for hurricanes over a period of what, about 15, 20 years. And this is what they're all going. They're going in so many different directions. So if you are a meteorologist trying to determine where is it going to land, you know, you have to work that out for you because it's practically impossible. You can determine an area where they may hit, but it's very impossible to say it's going to exactly hit in this area. Now, usually what happens once they hit land, they usually disappear. You know, sometimes they're going to create a bunch of flooding and storms as they hit the land, but eventually they're going to dissipate once they hit land. Here's I'm going to show you a map of where now we're we've ended up. We just ended the winter. We're going to spring, so the summer is actually now in the southern hemisphere. So here's a map that shows you where the hurricanes in the world are. There are actually none right now, even in the southern hemisphere. But you can see for the week of April 8th, here's where the tropical depressions and so have been happening. So nothing really strong yet. Again, we are now just sort of like there will be June is when the fall will start. You know, basically no. I mean, is when so around May is when the fall is sort of starting. Like when our spring starts, that's when the fall is. So it's slowly becoming the heavy season for hurricane. Around May or so is when they're going to have a lot of hurricanes. And there was a few of them last time I checked. They were in it, but this is actually showing you the storm that we have in the southern hemisphere right now. So you know, again, a few tropical depressions and so on. Not many actual hurricanes or typhoons or cyclones in there, at least at this time. Right? So this map actually shows you activity. Again, if I look at this, if we have this was in the summer in August, you'll see a lot of activity in the northern hemisphere. So let me show you a quick, again, a little National Geographic explanation of what happens. We have a few, so like what we call the anatomy. When you look at the anatomy of a hurricane, you can have an eye. That's usually not stormy in the middle. So usually when the eye of the hurricane goes through, it's actually very calm. And it's one of those calm before the storm types. But the walls are usually, the walls around it, they tend to be usually clouds of air that is dropping, that's moving up and down. And they usually tend to be rain associated with those very wet set of clouds that are in many cases dumping huge amounts of rain. You have very rapidly rising warm air that is going up. And in many cases, it creates walls of that are usually where the heaviest damage of the hurricane happens, because these walls are moving very fast, the winds are very, very, very fast, and they're loaded with water. In many cases, as they hit land or as they're moving through, they're dumping huge amounts of water as they're moving through, right? So anyway, let me show you this National Geographic video that sort of explains a little bit of the mechanics of a hurricane. Let's play that in a minute. Let's see, I'm just finishing up taking roll right here. All right. One more second. All right. So so anyway, so that's in very general terms what a hurricane is, happens. So here's if you look at some of the past of this is hurricanes that were tracked from what's it, for a period of 19 years. And you can see the past of these hurricanes, where they originated and where they ended up at. And again, you can see at least the ones here in North America, usually they're going to start in the middle of the Atlantic, and many of them are going to hit straight into the Yucatan Peninsula. Some of them are going to go into Mexico, the Gulf of Mexico, part of Texas. Many of them are going to hit Florida, and then a lot of them are going to go towards the Carolinas. In the Pacific, we don't have as many. Again, we never have them brought off of our coast here because it's just too cold. The water is just too cold. But we do have them in the Pacific side. We are going to have them, say, in the southern part of Mexico. And many of these hurricanes that you can see the paths, they are being propelled by the easterlies. And at some point, these the ones that I'm pointing right now, they were going to go and hit the tip of Baja. In many cases, as they move in by the westerlies hit them, they may get right through the Gulf of California and spew a lot of moisture, a lot of rain into the deserts of Mexico. In the summer, sometimes when we have hurricanes in the Pacific, sometimes we get what we call the tail of the hurricane. We may have some rain in the middle of August or so, and it's usually because the end of the hurricane went right through the Gulf of California. And sometimes it makes the turn by the westerlies, hit it right around Guaymas, around Sinaloa area, and they get through all the way up to the deserts. And at some point, they're just going to dissipate. Again, once they hit land, they dissipate. But and again, of course, in Asia, you can see the paths. Again, there you also have westerlies and easterlies. They usually get put by the easterlies to the coast of East Asia, and then in many cases they get turned around by the westerlies, and they're gonna hit areas around China. But Japan is kind of like California. Very rarely they're gonna have hurricanes there because it's already the water is just way too cold up there. And you can see the paths. Right now, this is what we're dealing with in the southern hemisphere. So again, where they're gonna end up is gonna depend on how the winds are where they're pushing. You can see that they can cause a lot of damage, and now here's how we measure the strength of hurricane. Unlike tornadoes, in the hurricane we do measure the speed of the wind. Here's what they use what is called the Saffir-Simpson hurricane scale. That is rates hurricanes based on the speed of the wind. Right? So again, from different amounts of wind, knots are what they call nautical miles. That's what the navigators, people in ships use to measure the speed of winds on the ocean. It's a little different than what happens on land because of friction. And so, I mean, you know, so different ways that they measure that. But you can see category 5, you can have speeds up to 157 miles an hour. And again, we have now hurricanes, typhoons that are even higher than that. They've been clocking typhoons in Hong Kong one time they get about 160 miles an hour. And they run out of categories now. They have to start calling them like super typhoons and stuff like that. Again, the most severe ones are going to be the ones where the speed of the wind is the highest. In many cases, while the wind is very damaging, remember the wind, once it hits the land, um, uh, then it begins to lose the power. So the winds are going to cause damage, and the rain associated with it, the falls that is basically dumping a lot of rain, is going to create a lot of problems, a lot of flooding, and so on. But the biggest problem is actually storm surge. As a hurricane begins to approach the coastal regions, you can see a normal tide over on the first picture on the right, the one I'm pointing out to. So here's the tide. When the hurricane begins to hit, the level of the water begins to rise. In some cases, can get up to 6-7 meters up high. And so what causes most of the destruction in a coastal region is not, I mean, the wind is going to cause a lot of it, but a lot of it's going to be the water, particularly the storm surge that hits the coastal region. That's the one that's going to cause a lot of damage. And again, now what's happening, a lot of these storms are stronger, the winds are faster, and the biggest problem is they're moving very, very slow. With the wind sort of tend to keep them moving very slow as they approach the land, basically dumping huge amounts of water. Harvey, that hit I think by 2017, I think it was. It just stuck around and around off the coast, near the coast, near Houston, and it just kept dumping water because it wasn't moving, and it flooded the entire. Houston was totally flooded because the hurricane wouldn't move. It happened with one of Michael, I think it was in Florida 2 years ago or so. They're just not moving very fast anymore. And when that happens, it can cause a huge amount of damage because they dumping a lot of water. In some cases, people were reporting with Michael that entire beaches were disappearing because they were picking up all the walls were picking up all the water, and it was start spinning it, and so they'll pick it up on the beach. The beach will basically clear out, and then we'll dump it like a 3-4 miles on the other side into the town, dumping huge amounts of water. So lots of flooding that went on, and so these are some of the most dangerous problems that happen. Just before we go here, I'm just going to show you how Katrina, a very damaging tornado, hurricane that happened in Florida and New Orleans. Um, Here, how it started out. It started as a Tribe 1. It begins to hit around the Bermuda, around Bahamas, and so on. And by the time it hit Florida, it began to pick up. It was relatively not that strong, but then it went into the Gulf of Mexico and it began to pick up a lot. It was hot in the Gulf of Mexico. It began to pick up a lot of intensity. By the time it hit New Orleans, it was already a Category 5. You can see how the heat of the Gulf of Mexico began to lower the pressure,
Fuels the
the speed, and then the confluence of the winds again. The easterlies were the ones that were pushing it into the Gulf of Mexico, but at some point the westerlies picked up and it began to move it up towards New Orleans. And again, a lot of the stuff, the rest of it was history, incredible damage that it caused, and so on. Anyway, so these are continuing to happen. Again, these are pictures of Michael that happened in October 10th. I was actually teaching the class in the fall when it was actually happening. So I had like CNN showing it live as it was hitting. I was hitting the ground. And Michael wasn't all that just stuck around. It wasn't moving very fast, and it was pretty big. And this whole area suffered a lot of damage. again, you know, it's not live anymore. So some of the latest hurricanes that we had, I was talking about Harvey that flooded the entire Houston. You see people in boats, these are streets in the middle of Houston that were flooded. Florence and Irma, of course, caused a lot of damage. And there's Maria, one that pretty much devastated Puerto Rico. Maria hit, it was a category 5 that hit Puerto Rico right there. It totally hit it straight on and pretty much caused a lot of damage. So anyway, just we're gonna move on to start to talk about climate. I'm just gonna just briefly show you some of the videos of some of these hurricanes, and then we'll move on to climate. So anyway, let me make sure that I got everybody. Let's see, I was just looking at while I was showing some of the videos, so looking to make sure. See who I had here. Make sure I got a message. So let's see. No, no, Agustina Viles. Let me know if I'm going to mention your name. If you are here, I just don't see you on the. I'm not seeing you on. I'm not seeing your name up here. So if I mention your name, it means that I don't see you. So if you are here, if you are there, you get to tell me so I can give you credit for being here today. No, Diana Marina, Celia Dominguez. Celia, are you here? No, I don't see you out there. So Joshua. No. Mireya, I thought I saw you. Oh, there you are. Yeah. Rodriguez, Claudia, are you there? I see you. Kiara is here. Daniela. Anyone know what happened to Julissa? Anyway. And let's see. Laura Ruiz, I don't see. Petra is here. No, Andrea, right? No, I say Godina. Yeah, no, I got you. No, yeah, because I hadn't seen you earlier. So, and Leslie Velasquez tampoco, no? All right, guys. Anyway, so that I think I got everybody who's here. There's a few people that sort of have disappeared. I'm not sure what's going on. I probably have to check. I'm not discouraging you, but I don't know if you may have gotten some information from the campus that there are options now to withdraw from the class if it's handle this. You can withdraw. They call it an emergency withdrawal. It will show on your transcript as a EW, and it's not gonna hurt you. But those of you who have been showing up, I think you're okay. Now, if you have any questions, you know, pretty much we're going to conclude the class. I'm going to stop the recording in a second here. If you have any questions, you can stop. You can sort of stay on after I stop the class, and then perhaps you can ask specific questions that you need. So have a good one. Stay safe and healthy. Hopefully, I mean, I don't know how long this is going to go. I think it's going to keep going. We are actually right now at the top of the worst right now. And I know despite of what, you know, who was saying, we still haven't seen the worst yet. And hopefully we're doing well in California. I have been following a map that shows you actually what's happening. I think we just got about, 45 cases in Chula Vista. I think there's been a couple of deaths already in Chula Vista alone.
What?
Yeah, there's been a couple of deaths in Chula Vista. I
Oh,
think
wow.
45. I think up to today, I think it would be like 50 cases that we have in Chula Vista. So if this is not over, be safe. Again, follow the procedures. If we do go out, I know, you know, stores nowadays, they can't walk out without a mask. And I finally found some gloves the other day. They're hard to find. I finally found some at what do you call it, Smart and Final. They're having for kitchens and all that. And I finally some disposable gloves that I can wear when I go out. So
That's good.
I have to go to the store. So anyway, you guys, have a good day. Stay safe, stay healthy, and we will see you
Take care, teacher.
What's that?
I said take care. Bye-bye.
Working on your key concepts. Alejandra,
Okay.
are you
Thank
still
you.
there? Alejandra?
Yeah, but
Okay. You wanna stick around a little bit? I know
yeah,
people,
that's okay.
let me go ahead and stop the recording and
Bye-bye, everybody.
Have a good day.
hey guys. I'm just gonna stop the recording.